problem here, BC number 3, Form B, 2010. And we have a cylinder situation, and it tells us that with the cylinder that we have, that figure above shows an above ground swimming pool in the shape of a cylinder. Radius is 12, height is 4. As we can see, the pool contains 1,000 cubic feet of water at time 0. And during the time interval 0 to 12, the water is being pumped into the pool at the rate of P of T cubic feet per hour, which is given by our table. And ultimately, the table above gives those values. And during that same interval, the water is leaking from the pool at a rate of R, which is given by a function. And they gave you the formula for the volume of the cylinder. Hopefully, we knew that without having to be told that, but give it to us nonetheless. So ultimately, we got water going into the tank based on this function, water going out of the tank based on this function. And so in part A, we're asked to find the midpoint Riemann sum with 3 subintervals of equal length to approximate the total amount of water that's been pumped into the pool during that time frame. And so ultimately, if we're going to set up our midpoint Riemann sum, we can see that if we're going to go 3 of them, our interval is 12, so that means that the interval length is going to be 4. Go from 0 to 4, 4 to 8, and 8 to 12. So we're at 4 on the outside, and then our heights are going to be measured at the midpoints of those 3 intervals I mentioned. So the midpoint of the first interval would be at time 2, which is 46. And then time 6 would be 57. And time 10 would be 62. And if we add that all up, we get 660 feet cubed. And 2 points, one for setting up the midpoint sum correctly, and one for the right answer, 660. Questions on part A. And part B, it says calculate the total amount of water leaked. And the amount of water leaked is going to be given by the area of that rate function on 0 to 12. So R of t, which is 25 e to the negative 0.5 t. And ultimately, it's a calculator problem. So if we put that in there, you should get 225.594 feet cubed. 2 points, one for the integral, one for the answer. Questions on that one? Alright, okay, part C. So use the results from part A and part B to approximate the volume of the water in the pool at the time 12 hours. And so it says, and round your answer to the nearest cubic foot. Well, ultimately, how much water was in there at the beginning? It was 1,000. And then we added approximately 660. And we subtracted 225.594. So again, it says use the answers from the first 2, which means ultimately use your midpoint sum here. Okay. And this one we can actually find an exact answer, and ultimately if we add those up, we get 1434 feet cubed. And that was worth just 1 point, which is not surprising. Oh. Questions so far? Okay, part D. Says find the rate at which the volume of the water in the pool is increasing at time 8. Alright, so find the rate at which the volume of the water is increasing at time 8, and then how fast is the water level in the pool rising at time 8, and indicate both units of measure. So ultimately it's a related rates problem. And we know that we're ultimately after dV dt here first, because we want to know the rate at which the water volume is changing at a particular time. And so if that's what we're looking for, if we write an equation that relates our variables here, we know that really there's only one equation here in terms of the water itself. The water is going to be of a volume pi r squared h. And keeping in mind that in this problem, if you look at that water, does the water radius ever change? So that's not a variable, which is good. It makes our job even easier. So it's actually 144 pi h would be our volume equation for this water. And ultimately, the question then is, can we figure out if we knew dV dt here, if we differentiate with respect to time, we're going to get 144 pi dH dt. And so, again, the issue here is, can we figure out the dVdt or dHdt? Well, do we know either one of those? In fact, isn't dHdt the other question that we're trying to answer here? It says how fast is the water level in the pool rising at that same time? Okay. All right. So I guess bottom line is there anything else that we could do to figure out what our volume change rate is? Okay. Keep in mind here that dVdt, remember, it's ultimately, think about the units here. It'd be a measure of cubic, what are we in feet? Cubic feet per hour, right? It's in cubic feet per hour. Isn't this P function in cubic feet per hour? Isn't that the rate? And what's R measured in? Cubic feet per hour. Remember, those are rate functions there. Those aren't volume functions, right? So let's think about it. If we knew the rate that the water was getting pumped in at time 8, and we knew the rate at which the function or the was getting leaked out at that same time, okay, wouldn't it just be the difference of those two? The rate of change of the water. If we do something feet cubed per hour minus something feet cubed per hour, we still get what? Feet cubed per hour. Okay, the rate of change of the volume is just going to be, in this case, it's just going to be the P function at 8 minus the R function at 8. Okay. All right, 'cause again, we're pumping water in at a certain rate, and then we're pumping water out at a certain rate. Okay. The difference of those is going to be the rate of change of the volume. Okay. So what do we know about P of 8? P of 8, it says 60, it's right from the chart. And R of 8, we know is 25 e to the negative 0.05 times 8. Right. So if we put our function in there, and we do the math, turns out to be 43.242 feet cubed per hour. So that's actually the answer for the first part. That's our dVdt. That's our rate of change of the volume. Okay. And then once we know that, now we've already done most of the legwork to get dHdt here because we know how D and H are related. Now we use our related rates information and we put that over there. So ultimately we just need this divided by 144 pi and we'll get our dHdt. So let's get that number in the calculator, make sure we get it right here. So 60 minus 25 e to the negative 0.05 times 8. Right, so there's the actual answer, and again, that's on our left side of our equation here. So if we divide it by 144 pi, we get our dHdt equals 0.096. And again, that would be in feet per hour. It's a comparison of H and T, dHdt, the rate of change of the height with respect to time. Ultimately on top, H is measured in feet, T is measured in hours, so ultimately 0.096 feet per hour. Questions on part 4, part D I should say. Alright, point breakdown. If we found the rate of change of the volume, that was worth a point. If we wrote an equation relating dH and dt, that was worth a point. If we found dHdt, that was another point. And also if we got the units right, so these two right here, these two units, 1 point. We're getting those two, feet per hour and feet cubed per hour. So again, if you made a mistake in here somewhere, you still could get at least the units point, because you should know that's a volume change, so it should be feet cubed per hour. That should be fairly easy to get those. And same with dHdt, it's a height changing with time, so it should be some length unit versus hours per hour, if you will. And also this part too, just knowing about related rates. We know that we have some rates here with respect to time. If we do our related rate stuff, even if we couldn't find the answer dVdt, we could have gotten at least 2 of the points probably. Alright, questions on part D? Okay, let's take a look at number 4. So 4, we have a graph that gives us a velocity. This is our velocity graph versus time. We have 18 Time units, what are we doing time units? Seconds or minutes, or it doesn't say, does it? No, it doesn't say. So whatever the 18, whatever time frame, the velocity is also unitless. So ultimately in part A, question says, at what times during this time interval 0 to 18, if any, does the squirrel change direction? And ultimately we know that if we have a velocity graph, that the squirrel changes directions when the velocity equals 0, but not only when it's equal to 0, but also when it changes from positive to negative. So that means that for part A, you should have had time, looks like time 9 would be change from positive velocity to negative velocity. So time 9 would be 1, and then also time 15. So times 9 and 15. And ultimately it says give a reason for your answer. Okay. And simply put, the velocity changes from positive to negative. And vice versa. So at 9 it changes from positive to negative. 15 it changes from negative to positive. Okay. That indicates a change in direction. Positive velocity means we're moving in a positive direction. Negative velocity just means we're moving in a negative direction. 2 points. One for the two numbers and one for the explanation. Questions on part A so far? Alright, part B here says at what times in this interval from 0 to 18 is the squirrel furthest from building A? And how far from building A is the squirrel at this time? So bottom line here is we're starting at building A, that's our starting point. And what's going on in the first part when we have that positive area? The squirrel is going in a positive direction. And then once we get to that time 9, what's happening? The squirrel's doing what? He's coming back towards building A. Comes back for a while, and then once we get to time 15, then he's going back away. So the issue is where is it going to be that ultimately that maximum point? And we can see here that our candidates really are only, and again, since it's a closed interval, I would always do the candidate test. And anytime the derivative, or the velocity equals 0 here is going to be a candidate, so we'd have 0, 9, 15, and 18 would be our 4 choices. And at time 0, our position is what? Yeah, position is 0. So if we make a little chart here, our position is 0. At time 9, we get to figure out how much positive area was accumulated. But ultimately that shape is a trapezoid, so it'd be 1/2 times the height there goes from 0 up to 2. The two bases are from 0 to 9, which is 9, and then from 2 to 7 on top, which is 5. And so ultimately we get 14. Alright. And, oh, not 2, but 20, sorry. 20 is the y value there that we see. So that actually be 140. So we're 140 in the positive direction, or in other words, 140 away from the building. At time 15, we're calculating another one. This one has a 10 height, same shape though, trapezoid. Going from 9 to 15, that's 6. On the bottom, we're going from 10 to 14, that's 4. And ultimately, we would have accumulated 5 times 10, that'd be 50. But that would be negative 50, so our new position would now be at positive 90. So again, we're going 0. We're going to go 140 to the right. And then this equals 50, but it's in the negative direction, so now we're back to 90 away from the building. So we went back closer to the building. And then ultimately the issue is, if we go from the last 3 minutes or whatever time unit is here, does it get us past 140? Or is 140 the answer? Let's find out. The other shape, again, is a trapezoid. Got 1/2. This time the height is 10. The bases are on the bottom, it goes from 15 to 18, that's 3. And then 16 to 18 on the top, that's 2. And if we add that together, we're going to get 25. So ultimately, these two added together would be 115, would be our total. So these would be our final positions after those time intervals. And so ultimately, when are we farthest from the building? At time, farthest from the building at time 9. And how far are we from the building? 140. And again, they didn't give us units, so 140, whatever. So time 9. And the distance would be 140. 2 points. One for doing the candidate work, Alright, and again, anytime you see a closed interval, I would always take that approach. That candidate test approach is always the best approach when there's a closed interval. Right? So instead of trying to use the first derivative test or second derivative test, just use the candidate test. It's a closed interval. And then one more point for the correct answer. Alright, and on part C, total distance traveled, we know that's just from 0 to 18 of the absolute value of E of t dt, which ultimately means the shapes that we just found the areas of, just need to add them together, counting the negative ones as positive. So we'd have 140, 90, and 25. Oops, not 90, but 50, sorry. 90 was our result, so these three add together. And so she get 190 and 25 at 215. Be our total distance traveled. 1 point. Questions on that one? Okay, see what we got here on the last part. It says write expressions for the squirrel's acceleration, velocity, and distance from building A that are valid for the time interval from time 7 to time 10. Okay. So, if we got time 7 to time 10, we can see that that is a line segment. True? So that means our velocity here is going to be linear, and we're going from positive 7, 20 to 10, negative 10. So our change in x here would be negative 10 minus 20, that's negative 30. Over 10 minus 7, that's 3. So our slope would be negative 10. And then our other issue is how about the y-intercept here? Okay, if we're going to find the y-intercept, we ultimately need to take one of our points here, and let's say we use 7, 20. So if we put a 20 in there, keep in mind this is going to be plus b, if you will. And if we go negative 10 times 7 plus b, we can get 70 here, negative, add it, we get 90 equals b. And so there's our velocity equation. It would be negative 10t plus 90. You could also put that in point slope form and just solve it for y as well. Either way is fine, but ultimately we want an equation for velocity here, so we should solve it for y either way. So that gives us our velocity equation. And if you did that correctly, you got 1 point. You got the right velocity equation. And how do we get our acceleration equation? The derivative of the velocity is what? Negative 10. So acceleration equation then would be negative 10, and point for that. And the position equation we know is the antiderivative of the velocity, so it would be negative 5t squared plus 90t plus c. And the other issue is what about c? We're going to find that c. We know I got this part right here. Okay. That's pretty simple. It's just the antiderivative. Okay. So how are we going to find c here? Any idea? Say it again. Well, remember the key issue here, though, is that this needs to be an expression for position between 7 and 10. Okay, so keep that in mind. It needs to be between 7 and 10. I mean, if we were to write an expression here, and the problem of using 0, 0 here is this velocity equation is only good for 7 to 10, isn't it? All right. So with that, question is, how can we incorporate the 7 to 10 in here in order to figure out what our c is? Well, let's think about if we did from 7 to 10, if you will, what would be our initial condition then if our initial time was 7? Could we figure out a y value for position at time 7? And ultimately, wouldn't it be the area under the curve from 0 to 7? Which would ultimately be the trapezoid, not this one that we did, because that goes to 8 or whatever, or goes to 9 actually. but if we did it from 7, then our area would be 1/2 times the height, still 20. And then on the bottom we'd go from 0 to 7. On the top we'd go from 2 to 7, that'd be 5. And so we get 10 times 12 would be 120. So 120 would be the position at time 7. True? So let's see what happens if we put in 120 here for position and we put time 7 in here. Let's see what C that creates. So here we're going to get 49. 49 times 5 would be 49. 50 times 5 would be 250. So 245. And if we add those together, we're going to get 385. And subtract, we get negative 265. And so ultimately that would do it then, wouldn't it? Keep in mind again, we're essentially making our initial point here instead of time 0, we're making our initial time be time 7. Okay, so if we know the time and the position at time 7, okay, we can use that to find our C that we can use for this time frame. And ultimately again, we got to make sure that when we actually answer the question here, we'll put our answer as negative 5t squared plus 9t minus 265. And getting that was worth 2 points. I'm going to guess in grading that, I would assume that if you got the antiderivative plus C part right, you get a point. And then if you found the actual correct C, then you get another point, because that was worth 2 total. Any questions on anything we did on that one?